Next section in the KMAP we can call as a don't care terms. What is this don't care terms or don't care condition? It is incompletely specified function. In some logic circuit, certain input conditions ever occur, therefore the corresponding output never appears. In such cases, the output level is not defined. It can be either high or low possibility. These output levels are indicated by X or D in the symbol. In the truth table, we are calling this one as a don't care output or don't care condition, or even we can call it as a incompletely specified function. So, simple way we can say that it is the combination of which we don't have any output expression. In the binary, either we have 0 or 1 output, but some condition we don't have either 0 or 1. That particular case is known as don't care combination or don't care condition. This can be expressed in X symbol. In this we can check how to KMAP can be designed using this don't care condition. There is some general rules in the don't care condition. It can act as a 1 or 0 also possible in the KMAP. So in such a no such group can be encircled whose all the elements are X. This is the very important first condition. In anywhere in the KMAP, only don't care is there. We cannot make it that group. Any group of the don't care, at least one should be present in that. That is, number of 1 is actually present in that particular group. So then only it can be grouped in the KMAP. One more condition of the don't care is that if it is 0 is there, we cannot do the 0 grouping with this X. So in the simple way, the don't care has a 3 condition. One is it can be grouped with the ones, it cannot be grouped with the only don't cares, and it cannot be grouped with the 0. One example we can take, the best example is BCD to XS3 conversion. Now, what is this BCD means? We know that BCD is binary coded decimal. It is a system of writing numeral that assigns a 4-digit binary code to each digit 0 through 9 in a decimal that is base 10. It is also called as a weighted numbers. In this 4-bit BCD code, for any particular single base 10 digit, it is representation in binary notation. So, this is as known as about the BCD. Now, we can discuss about what is this XS3 code. XS3 code, name itself says, it is the addition of 3 to the BCD or XS3 to the BCD. If you add any 3 to the your BCD number, whatever output you will get, that is known as XS3 number. So we can do the truth table of this representation and we can do the similar way. So if you take as a one number something called as a 0, so representation of BCD usually we call as a weighted one, and first LSB is weighted 1, then 2, 4, 8. So for 0 number all are 0. 3 means nothing but addition of 3. 3 means the weightage of first one is 1, second one is 2. So 2 plus 1 is 3. So for 0, 0, 0 we are getting output is 0, 0, 1. Similar way, if it is 0, 0, 1, so output is 4. Like that we can get up to 9 numbers. Listen carefully, the very important in this truth table is the BCD is a base of 10, so maximum number is 0 to 9. If you are taking 4-bit number, we will take 0 to 9 and 9 is addition with the 3. So it is start from 3 to 12 is the output of your XS3 code. So now the next condition here, what happens to other numbers? If it is 4-bit means we know that 0 to 15. So after 9, 10, 11, 12, 13, 14, 15, what happens? What is the output of that number? We cannot represent in BCD, so output also you are not care about that. For that condition, we are taking as a don't care condition. Before going to that, here we can check out the each notation for that. If you take the first number is W here, and next one is X and Y, Z. If you take the XS3 code, there is a 4 notation W, X, Y, Z, and W is present 5 conditions. In this we are calling as it is present in 5, 6, 7, 8, 9. So we can call the W equation is 5, 6, 7, 8, 9. Similar way, X is present in the particular case 1, 2, 3, 4, 9. Similar way, Y is present in, this is the Y case, okay. Y is present in 0, 3, 4, 6, 7, 8, and similar way, Z is present 0, 2, 4, 6, 8. This is how we can form each number, how it is we are derived from the truth table to notation part. Now we can discuss about the what happens after the 9, that is actually we are taking 4-bit here, but BCD is maximum 0 to 9. What about others? We know that in 4-bit 0 to 15 is present. So 9 to 15, whatever the number is there, we are not getting any output for that. That particular condition we are calling as a don't care condition here. So once you check here, the output after the 9 and up to 15, we are making as a X cross, and we are not bothered about what is output here. And this is actually in the BCD is not required because BCD is maximum 9 only. So in this condition we called as a the don't care for these part. If you take as a W to the next addition here, we can make the all the term whichever next, that is 10, 11, 12, 13, 14, 15. These all are don't care condition. These we can represent D, okay, D of all these stuff 10, 11, 12, 13, 14, 15. This is similar to the X and similar to Y and similar to Z also. So we will go to KMAP and we will discuss how it works. First we will take as a how to draw the W in the KMAP. So previously we discussed W is present in 5, 6, 7, 8, 9 and the don't care condition present after the 9. So we will make these ones and other part is 0. From this truth table we can represent the KMAP. So KMAP 5, 6, 7, 8, 9 is present. So the other part 10, 11, 12, 13 are don't care. So make it those portion with filling with X. Now how to do the grouping for this one? The don't care condition we already told there is a 2 rules in the group. One is we can group with the any one, or we cannot group with the only don't care. So here we can do grouping of 4 numbers of 1 and don't care possible. We cannot do only don't care portions. Here first we can do this number of 8 number of group possible here, because in this 8 and 9 are 1, so we can make group of this. And one more group we can do, the 5, 7 is left, so we can do group of this 5, 7, 13, 15. And here 6 is not involved in any group, so we can make one more group possible, that is 6, 7, 15, 14. So in this we have 3 groups. Each groups, what is the equation we can represent? The first group in this equation, it is all the column is present, so all the column will cancel out. Only we will get the 2 rows, that is AB and AB bar, where A is the common part and B and B bar get cancelled, so we are getting A for this answer. If you take this 5, 7, 13, 15 group, in this group what happens? In the 2 columns C bar D and CD, the D is a common, C will get cancelled, C and C bar. So the rows are A bar B and AB, so A is get cancelled, it changes, B is common, so it is DB. One more group we have 7, 6, 15, 14. In this group we can say that the CD, CD bar, so D bar get cancelled, C is same. Similar way, A bar B and AB, the previous operation only, the A bar A get cancelled, so you will get B. From this you will get the 3 portion, one is A plus DB plus CB. This is how we can do the K-map using don't care condition also. The major rules of this don't care condition, we cannot make only the group of don't care. There must be at least the ones present anywhere in that group. That is the major rule in the don't care. Now we can do the logic diagram for this one. The first one, the A present, make it A here. Second one, DB present. So D is present somewhere here and B is present here. Then CB, so C is present here and B is present here. So the top three of the output we are calling as the output of the MSP bit is W of the XS3 output. Present in 1 and 2 and 3, 4 and it is present in 9. And don't care condition are after 10 it is 10, 11, 12, 13, 14, 15. So present according to the your KMAP also you can check that you will get it. We can do the grouping something called this 1 and 3 we can do grouping and 9, 11 we can do grouping and then we can do grouping of this 4 and 12 and we can do grouping of this 3, 1 and 11, 10. These are the grouping possible here. When you are doing grouping, remember that we cannot do grouping like 9, 11, 13, 15. Why? Because here 9, 11 already present in one group. So 13, 15 both are don't care and already present once in some cell and that cell we cannot group with the don't care condition. So 13, 15 and 9, 11 not possible. Anyway 12, 13, 14, 15 not possible because this is all don't care. So we will simplify this version. If you take this first group 1, 3 and 9, 11, in this we have C bar is different here. So D we will get here and from the first and last row it is B bar is same, A bar, A get cancelled, so it is D B bar. If you go with the next group 3, 2 and 11, 10, in this the same portion you will get as a rows that is B bar and here the D bar get cancelled and C is common. So it is B bar C. One more group you have that is two numbers that is this portion A bar A get cancelled so we will get B and then the full column it is only one column selected so C bar D bar. The final equation you will get something like that it is DB bar plus B bar C plus B C bar D bar. So according to this you can do the logic diagram for that. So wherever D is there make it D present high and B bar here then B bar C here B C bar D bar. So take these top three gate and you will get answer as a X. And remember that whichever portion not filled that better to fill with zeros. When you are doing as a any KMAP simplification you have to fill zeros and only do the particular portion of the logic diagram, don't include other portion. This template I used to make easy for you one after one procedure and some extra portion in the template you can neglect that. In the next Y portion already we discussed wherever it will 1 we will get. So 1 is getting in 0, then it is getting in 3, then it is getting in 4, then it is 7 and 8. Then the don't care is 10, 11, 12, 13, 14, 15. So all the other portion fill with zeros. So same represent in the KMAP. So 0 is present, 3 is present, 4 is present and then 7 present, 8 is present and 10, 11, 14, 15, 13, 12 are don't care. When you are doing grouping, here it is very easy grouping. See this 0, 4 and 12, 8, we can do group 4 numbers including 12 don't care and 3, 7, 15, 11 possible including don't care. Okay, not required 12, 13, 15, 14 because only don't care not possible, and 15, 14, 11, 10 also not possible because only don't care. So we have only one group. So already we discussed if all rows selected, we can cancel and make it 1, and only the C bar, D bar is present in the one particular column selected. Same thing here, all the rows selected, so make it 1, and the column is selected CD. So it is very simple that we have C bar, D bar plus CD. You can use XNOR gate for this also for particular equation. Here I am doing logic gate using some basic gate only. So wherever C bar is there, this C bar and D bar and the C and D, these two are selected. So we got as a first two output. This is the logic diagram representation of your Y on the XS3 output. And the last LSB bit Z present in high at 0 and 2 and 4, 6 and 8. So make it 1, and after 10 it is don't care. Make all the position don't care, and whichever portion not filled, fill with zeros. Same thing represent in the KMAP also. It is present in 0, 2 and 4, 6 and 8. Then after 10 all are don't care. When you are doing grouping, you have to do maximum numbers of group. So this wrapping is possible left side to right side. So 0 portions and these 2 portions you can do it together, and all the 8 numbers, and left is 13, 15, 11 is don't care, so we can leave that. So this grouping we can take as something like that. Here all the rows are selected, so cancel this. The column 2 things are selected, C bar, D bar and CD bar. So D bar is common, so your answer is simply D bar. So if you're doing as a logic diagram, make it D bar and take Z here. This is how you can get as the output of the LSB of the XS3. So this example taken for how to do for the don't care condition. The summary of don't care condition, you can do don't care for only if essential number of 1 present. And don't care cannot be done with the 0 grouping, and don't care cannot be done with only one don't cares, and also don't care cannot be done if the one cells is already present in other group.